Just to let you know, I have graded your Chapter 5 test so that you can see what your grades are. I don't know if I'll get them back to you today, but if I don't today, I'll give them back to you for sure tomorrow. I know there's a few people that still need to take the exam. But Chapter 6, we are going to continue our work with probability, and specifically, we're going to talk about random variables. Okay. And we'll talk about what we call discrete random variables. Later on, we'll talk about what we call continuous random variables. Okay. So, and we're going to show you how to do all sorts of different calculations with them. Combining random variables, okay, adding them together, subtracting them, and taking a look at certain calculations from them, including mean and standard deviations. Okay. So, first of all, okay, when we talk about a random variable up here, okay, it's a variable that basically takes on some sort of numerical value in some sort of chance variation. Okay. So one of the things that I could take a look at is I could, take a look at, for instance, rolling a six-sided die. When I roll a six-sided die, those outcomes have numerical values. 1, 2, 3, 4, 5, 6. Those are the actual outcomes. And then I'll have probabilities assigned to them. So, in Chapter 5, we talked about this kind of probability distribution. We'll define some random variable x. We'll look at all the possible values of x, and then all the probabilities that are assigned are given to those values. Okay. So, for instance, like rolling a six-sided die, we've already looked at this one time. The outcomes are 1, 2, 3, 4, 5, and 6. The probability of each outcome, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. Again, assuming that the die is fair. So one of the things that I want you to be able to do today, okay, is to be given a random or a situation that defines a random variable. Be able to define it in terms of a variable x or y or z, and then be able to come up with this probability distribution. So that's what these first couple examples will ask you to do. So on the first one here it says, you toss a fair coin 3 times and record the number of heads obtained. So here it says define the random variable x. So x has to represent numerical values. X is going to equal the number of heads you get in 3 coin tosses. I do that all the time. Number of heads you get in 3 coin tosses. Whoa, hate it when that happens. Sorry. Trying to scroll a little bit and it jumped on me. So now in part B it asks you to make the probability distribution for the random variable x. So we're going to make a table here. Here I have x, and here I'm going to have the probability of each of those outcomes. So if I flip a coin 3 times, how many heads could I get? What could be an outcome?
3 heads.
3. What also could be an outcome?
Tails.
Right? I could get 2. I could get 1, or I could get 0 heads. I'm actually looking at the number of heads I'm actually getting. 3, 2, 1, or 0. So now I have to figure out the probability of these. So to figure out this probability, it might be helpful for me to start listing out or visualize what the sample set is going to look like. For instance, getting 3 heads would be heads, heads, heads. 3 H's in a row. That's the only way I could probably get it. However, getting 2 heads, Well, that could be the first two are heads and then a tail. It could be the first and the last. Or it could be the last two coin tosses. I'm not done listing out all the different outcomes because now I can look at getting just one head. Well, I could get it on the first coin toss, or I could get it just on the second coin toss, or I could get it just on the third. Then when I think of 0 heads, that's all tails. Tail, tail, tail. So now when I'm calculating out this probability, what's it going to actually be out of? It's actually going to be out of 8. So all of these are going to be out of 8. How many of them up here have 3 heads? How many of them have 2 heads? And 1 head? And 0 heads? Okay. Now, one of the things that I do, and we've talked already a little bit about this, but once I get a probability distribution here, one of the things that I want to do is make sure it's legit. So down here at the bottom, I know I have another example. Down here at the bottom, when we talk about our probabilities in a distribution, these two things must be true. Every probability has to be a number between 0 and 1, and all of my probabilities have to add up to 1. So when I do a probability distribution like I just did, I check those two facts. I know they're all fractions, I know they're all between 0 and 1, and do these all add up to 1? Well, since it's out of ace, I can add up my numerators. 1, 3, 3, 1 add up to 8. 8 over 8, I've accounted for all my outcomes. Therefore, I've done it correctly. All right, are we okay with the first example?
Yes.
Beautiful. Let's try the second one. It says, you roll a pair of dice and find the sum of the spots showing on the up faces. Define the random variable x. Well, x basically equals the sum of the dice and I really am going to redefine this. Sorry, I don't like that answer. I didn't want to delete all that. See, now it's going to do that because I hit it way too many times. My apologies. I'll rewrite these answers here. That's all right. I know I make mistakes. So, x is the sum when rolling a pair of 6-sided dice. I like that at least a little bit better. I know up here it just said roll a pair of dice. I'm going to assume they're 6-sided because I know there's going to be usually one person in a statistics class that will say, well, how do you know how many sides it has? Because there's many dice out there that are not 6-sided. So now, B says make a probability distribution for this random variable. Ooh. So I have x, and I have p of x. What's an outcome I can get when rolling a pair of dice? 6, 12. Can I get 21?
24.
No. Remember, we're adding the sum of the two dice. What's the lowest number I can get when rolling a pair of dice?
0.
I can get 0?
Snake eyes.
I can get snake eyes, right? A 1 and a 1. So my lowest value is a 2. What's my highest value?
12.
Okay? Is every number in between 2 and 12 a possibility?
Yes.
All right. So, wow. This is a big probability distribution table. 11 different outcomes. So now, I'm I'm not going to expect you to go back and pull out this packet, but you could reproduce this rather quickly. If I go back to my 5-3 notes right here, alright, I have all the outcomes listed here. If you remember back in chapter 5-3, we use this to figure out certain probabilities. These are all my outcomes. There's 36 of them. So I know the probabilities of all 11 possibilities that I have rolling a 2 through a 12 is going to be out of 36. So I just want to figure out how many of them there are 2s, 3s, 4s, all the way up through 12s. You'll start to see a neat little pattern here. Okay, I have 1, 2. It's got to be snake eyes, as some of you like to say. 2 3s, 3 4s, 4 5s, 5 6s, 6 sets of 7. Is it 7 sets of 8?
No.
No, it decreases. And then it goes 5, 4, 3 sets of 10, 2 sets of 11, 1 set of 12. So it goes up to 7. No, I'm fighting something going on with me right now. So probability of getting a 2 was 1 out of 36. And this increases by 1 until I get to the sum of a 7. Whoops. This should be 4 out of 36, 5 out of 36, 6 out of 36. And then it decreases back down by 1 until you get to 1 out of 36. Now the good news is all my probabilities, again, I know are between 0 and 1. That's usually pretty obvious to see. Do they add up to 1?
Maybe.
Maybe. Watch this. What does 1, 2, 3, 4, 5, the first 5 numbers add up to here?
15.
15. I have that same here, right? 15 and 15 is, and then I have this 6 makes 36. So I add those up pretty quickly just to verify, hey, all my probabilities do add up to 1. Okay. Now, one of the things that we are going to just talk about a little bit here today is what we call a discrete random variable. And I apologize because really in this, when we talk about random variables, there's 2 different types. The first one that we're going to talk about is called a discrete random variable. Okay, it's discrete. We don't talk about it that very much. Exactly. Okay. Sorry, Alex.
When we're doing this, do we reduce our fractions or just keep it?
I only reduce if it's like a final answer. If it's in a probability distribution, I won't. Mainly because I think it's easier to work with those numbers. And you'll see later on, it won't matter to be reduced when we're starting to calculate out means and standard deviations. Okay. But good question. Okay. So now, a discrete random variable, basically what it means is we have a fixed set of possible values. Meaning there's only a set number of outcomes possible. So like when rolling a die, or I'm sorry, rolling a pair of dice, we had 11 outcomes, 2 through 12. There are 11 different possibilities with different probabilities assigned to them. It was a fixed number. It didn't go on forever like some of my lectures. Same joke. Thank you for laughing. Okay? For those of you who have to listen to that. Now, it also means there can be gaps in between the outcomes. Meaning, if I look here, there's a whole bunch of numbers in between 2 and 3. Technically an infinite amount of numbers. There's a gap. 2.5 was not a possibility to roll. Okay? Neither was 3.5 or 7.5 or 7 3/4. Okay, that's what it means by the gaps in between them. There are values that are left out in between your outcomes. So today we're going to just focus and use and talk about discrete random variables because they tend to be very common and used quite a bit out especially when we start taking a look at gambling situations. Okay. So let's flip to the next page because we've actually talked about the probability satisfying these two requirements. So we can go ahead and jump to here. One of the things that we want to be able to calculate out. We're going to show you how to calculate out now. And let me backtrack a little. Now that we know how to write these probability distributions, we want to perform some calculations on them. One of those calculations that we like to find out is what's called the mean of your discrete random variable. So if you're given a discrete random variable that has, some probability distribution that looks like this. You have an outcome. You have its assigned probability. You have another outcome with its assigned probability, and so forth until it ends somewhere. Okay? It will end. Okay? There will be a set outcome where it stops. Like with the rolling of the dice, it went from 2 to 12 and then stopped. So now, if I want to calculate out the mean, okay, another term for the mean is the expected value. Okay? And sometimes you'll see me talk about expected value more often than the mean. But those two terms go hand in hand. All you have to do to calculate it out is simply take each outcome and times it by its probability. Then take those results and add them up. That is going to be your mean. So you can see here in the formula, you take each outcome times its probability. Each outcome times its probability. And you do that for every single outcome you have in your distribution. And then you sum them up. Remember, sigma represents sum. So this symbol represents the mean, since it's a subscript, of your random variable x, where x is your random variable. So this is giving you the average. This is what your average outcome would be for one try. Okay? Whether it's one try or one person or one whatever the random variable is representing. If you're to do whatever you're doing and pick one random variable, this would be its average. Okay? A very useful piece of information to know. So, to show you how you do the calculations and how you interpret it, let's take a look at these next two examples. First one here says individuals applying for a certain license. Okay, so it could be they could be doing their bar exam, or they could be doing, they're applying to become a CPA, are allowed up to 4 attempts to pass the licensing exam. Okay, or they could be becoming a teacher. And I know I had to take a test too. I passed on the first time, thank goodness. Thank you. It says, let X equal the number of attempts made by a randomly selected applicant. Okay? So they allow you up to 4. And so this is the proportion or the probability that a randomly selected person only had to take it once, twice, 3 times, or 4 times. So in the question it says, find the expected value of X. Alright, let's do that first. So, the mean of X, or sometimes we'll refer to it as, I like to use the capital E, E of x, they go hand in hand, is equal to, we take each outcome and times it by its respective probability. So 1 times 0.1 plus 2 times 0.2 plus 3 times 0.3 and 4 times 0.4. Oh, sorry, I didn't realize I shut my calculator down. So it gives you a second to copy it, and then that's going to be right and smack in the middle. It always has to validate my software. It's just basically taking in my code I plugged in and go from there. So now, what's really nice is order of operation says your calculator will do multiplication before addition. So what's nice is I can just type this all straight in. It will do the multiplication first before it does the addition. So 1 times 0.1 plus 2 times 0.2 plus 3 times 0.3 plus 4 times 0.4.
That's a nice number.
It is a nice number. That usually doesn't happen for a mean of a random variable. So we get 3. So the question becomes, what does that actually mean in the context of the problem? Okay? Well, what it represents is the average. The average number of attempts made by a randomly selected applicant is 3 tries or 3 attempts. I'm going to replace tries with attempts. Boy.
Try that.
What's that?
Try that again.
Try that again. Thank you. So if you did it in less than 3 attempts, you were better than average. If you did more than 3 attempts, you were less than average. If you were actually 3, you were the average.
Above the average.
I'm not always above average on some things.
Like history.
I'm actually pretty good with certain history. So, not all. American history is my strength. All right, number 2. Oops, sorry, I know I go a little fast. Below is the probability distribution of a local school raffle. I like talking about school raffles, don't I? Okay? Let X represent the amount won by a randomly selected person who has just a single raffle ticket. So, if you look at what they're raffling off, this is kind of nice. They're raffling off $50 and $100, $250, $500, and $1,000.
And 0.
Nice, and nothing, of course. Okay? Find the expected value of X. All right. So let's do that. So, my expected value of X. Again, what I'm doing is I'm taking each outcome and multiplying it by its probability. Why do you think I did not circle the last one?
Because then it would turn into 0.
Equals 0.
Yeah, anytime I multiply by 0, it's 0. So no need to write that one because I know that piece is going to turn into 0. So 50 times 0.005 plus 100 times 0.001 plus 250 times 0.0004 plus 500 times 0.0002 plus 1,000 times 0.0001 plus 0. Okay. So, if I enter this in on my calculator, let's type her in and see what happens. Try to do this so that you can still see it at the same time there. So 50 times 0.005 plus 100 times 0.001 plus 250 times 0.0004 plus 500 times 0.0002 plus 1,000 times 0.0001. See if I did it right. Woo! 0.65. Okay. So what does that mean?
It just means it's 0.65.
Well, the average amount won by a randomly selected person who has one raffle ticket is a whopping 65 cents. So that's the average. Basically, what it's like saying is, if I distributed the winnings evenly among every single raffle ticket that was sold, okay, each person's going to get 65 cents. Not a whole heck of a lot of money, is it? But that's your average. Now, this is where expected value can become very, very useful. If I look at the next question, it says if 10,000 tickets were sold for $1 each, how much profit did the school make on this raffle? So how much are they charging? $1. How much do they actually have to pay out? 65 cents.
Nice job.
Okay? So basically you can look at it like this. They're making a profit, 35 cents profit per ticket.
Those cheaters.
How many tickets?
Over.
So they're going to make a total profit of $3,500. But they're only selling them for $1.
That's still a pretty good
The reason, some people are saying, well, it's not a ton of money, or some of you might be saying, well, that's a lot of money. Think about raffle tickets these days.